Page. Okay, a line of best fit or scatter plot. All the scatter plot is putting raw data on a graph. Raw data means it's data that has just been acquired. It's not been manipulated or worked with anybody. It's just data that's brand new data. Okay, and it's just raw, nothing done to it. Now, when you put this on a graph, you may or may not get a pattern, but you probably will not get a straight line. Okay, because the data is raw and it hasn't been tampered with, so it might just give you data. So when we plot these points, we're just going to see where they go. You'll see what a scatter plot looks like. Okay, so we got 4 and 12. Go ahead and plot your points on your graph. Okay, there's 4 and 12. Get your points plotted. 7's there, 11's right there. 9 and 8. 10 and 3. 12 and 4. 13 and 1. Okay. So I get my data posted, and I can see that there's some kind of pattern to it, but not a lot of data there to see really get a good pattern. But there is some pattern to it. You see what that pattern is doing? Okay, good. It's going down. What does that mean? It's positive or negative? Okay, so it's a negative pattern. What that means, guys, is this has a negative correlation. Okay, correlation means the points correlate to a negative slope. Okay, now, it's obvious that the more time spent watching TV, the less time there is spent doing homework. Okay, so I'm thinking that this child that spends 4 hours watching TV and 12 hours doing homework probably going to get a better grade than the one that spends 13 hours of watching TV and 1 hour of homework. So I'm pretty sure that's probably realistic. Okay? So, that's all scatter plot is. Scatter plot is just raw data thrown on a graph. Okay? Now, when that happens, if you look down the next group of things here, you're going to get some different patterns show up. Okay? These are called correlations. And there's what they call a correlation coefficient. Okay? Okay, so a correlation coefficient is a number between 0 and 1, 0 being terrible, the worst it can be, and 1 being perfect, and it could be negative 1 if it goes to negative graph. This is a perfect graph, okay? And so what the correlation means is this, okay? This one down here is a 0. There has no correlation down here. Okay? But this one right here, this is a positive, close to positive 1. This is almost a perfect graph. And so the tighter if you look at these, the tighter they get, the closer to 1 they get. Okay? This would be a positive 1. This would be a negative 0.9 or 0.989 or something like that. Okay? As these dots get spread more out, they become less correlated. Okay? So the correlation coefficient goes lower than 1. Okay? So this is negative, going down to the right, negative correlation. This is a positive correlation. Okay? This one is no correlation. There's no seemingly pattern to this. And this one here is called a nonlinear correlation. Okay? Remember the word linear means line, so if it's nonlinear, that means it's not a line. Okay? Alright? 0 means there's no correlation, and a 1 is a perfect straight line. So between 0 and 1, those decimal points will get us close. So this is about a negative 0.9 probably. Okay? Now, when we get deeper into this, we'll go into this deeper when we get to Unit 7. We'll talk about how to find that correlation coefficient, how to use it perfectly, but right now I just want to recognize what they are. Okay? Alright, so let me ask these 4 questions at the bottom here then. Which data set shows no relationship? Anybody know? There you go. Which data set shows a negative linear relationship? Which data set shows a positive relationship? And which data set shows a nonlinear relationship? Okay? So yeah, they're not that bad to look at. And those are on your assignment like that, okay? All right, first page is out. Go to page 2. There's 4 of these pages, by the way. Most of it's because of the graphs. Yeah, there's just lots of graphs, and they take lots of room. Okay, so again, same idea. What do we got here? What is this called? Positive. Is it tight or is it kind of loose? It's loose. Okay, this would be less than 1. This would be almost a perfect 1. Okay, this one is. And what's going on with this one? No, it's linear, but it's negative, right? And its correlation is kind of loose on this one. It's not real tight, okay? So, this is what it says. The question says, which data set has the correlation coefficient closest to 1? Yes, figure 2 does. As I can get. Which data shows the least evidence of linear relationship? Okay? Now, which data set has the correlation coefficient closest to 1? Negative 1. Yeah, because remember, it's the only negative one I have. So it's the only negative thing I have, okay? It's not very close to negative 1, but it's the only negative one I have. So it's the best one I have, okay? Okay, now, here comes the fun one, okay? All right, so on this one here, okay, this shows the revenue generated by millions of rental movies versus movies in theaters, okay? And we notice that as the movie in theaters are more popular, the rental becomes more popular. So this is a positive relationship. What they would like us to do is they would like us to draw a line of best fit. Now, a line of best fit is simply just that. It's the best fitting line I can get there. What I want is I want approximately half my data above the line. I want half my data below the line. And I want maybe some on the line. Okay? So I'm going to try and find the best line I can put in there that kind of does that situation. So I think what I'll do is pick this point over here. I think I'll pick 4 over here to have that endpoint be on 4. And then as I draw my line up through here, I'm going to do the best I can to get my data to go in between all this. Okay? So I think I'll put it right there. Notice there's no mathematical value here. I'm just putting numbers where I want them. And I'm trying to get that data, that line, to go in between all my data. How'd I do? That's not bad. That's all you got to do. Dude, that's all you have to do is get a line in the middle of all those dots somewhere. Yep, you got to make up your own line. Try and get half your data above the line. Try and get half below the line. If you want some on the line, that's great. That's the best you can do, guys. This is why it's called a line of best fit. It does not have to be exact. Okay? It's just your best approximation. Get in there somewhere. Okay? We're going to do that quite often in this assignment, so that's all you got to do. Okay? You're okay with that? Not that bad, huh? Okay, now, this next question tells us how to use the information. Okay, we know more about it this way. Okay, so on number 5 here. All right, this is the 25 vehicles, the fuel efficiency in miles per gallon, and the weight of that vehicle. As we see this, as the weight increases, the fuel efficiency tend to go down. But we have this point out here. This point's a weird point out here. It's kind of away from the rest of our data. This is called an outlier. Okay? An outlier is a data point like that that's outside your normal range of data. It just pops off one side. Okay? A real-life example of that would be if we took the average ages in this classroom, I would be an outlier. Because my data would be way out to beyond your age. Okay? So yours would be all clustered together at 13.9, 14.2, 15.1, something like that. And my data would be way out there. Okay? What? Pretty good chance. Okay? All right. Okay. So, for these 25 vehicles, as the weight increases, the fuel efficiency tends to do what? As the weight goes up, what happens to fuel efficiency? Everybody reading that? It decreases. Okay, and you'll have pull down menus on Alex to do. You just have to pull it down and see what's going on. Okay, so What kind of correlation is between these 2 points? What's this correlation? Yeah, it's negative. Okay, now here we have to be careful on. Hey, you need to pay attention on these details right here. Okay? Okay, so first thing, using the line of best fit. So we look at the line, nothing but the line. Okay, we don't look at the points, we look at the line. What would a 3,000-pound vehicle get approximately using the line? So we go to 3,000 pounds, we follow it up, till we find that marking point right there. Where is that point on that line? It's not 30. Okay, where is that? That's the thing. Where is that? Okay, now again, you have a pull-down menu, but realize that that's not 30. I don't care about the points, I care about the line. So according to that point, I'm going to say it's about 28-ish. 28.5 would be my best guess. You'll have a pull-down menu, and I'll show those to you. That's what you got to do. But the key on that one, folks, is you got to look at the line. Okay? Don't look at the data points. Don't look at anything else except where the line goes through there. Okay? And get your best guess. Okay. All right. Now, this is going to be the one that's going to drive you nuts. Okay? Because not only do you have to draw a scatter plot, once you draw a scatter plot, you need to find the equation of your line. Now, here's what you got to be careful of. You need to choose really good endpoints. Okay? The better you do on choosing endpoints, the easier it's going to be to get an equation. Okay? So I'm telling you right now. Okay? Madison, this is for you. Alright? Whatever says. Hey, listen. Because I guarantee you this. If you choose bad endpoints, you're going to have a hard time getting this equation. So you better pay attention. Okay? What I mean by good endpoints is this. We're going to write an equation of a line. So I want to look like this. Well, you can x plus b. So I want a good slope, and I want a good endpoint. Now, alright? So, when I do this, the first point I pick is going to be on this line somewhere. Make sure it's on this line. Right here. If you don't pick one on this line, you're going to get screwed up. And make sure you get one that has a good number to it. Don't pick 10.5. Don't put a point right there. That's not a good place. So my thing would say pick either 6, 8, or 10 and start there. I'm going to choose 8. The minute I choose 8, I've already got half my equation written. I've got my intercept. Okay? Everybody understand that?
Yeah.
So pick a good number here. That's your intercept number. Okay, don't pick it between 2 and 4. Don't pick something else. Pick a good number that makes you on a number. Okay? Now, your line then needs to go up through your points. And I'm going to get it up through here, and I'm going to pick another good point up here. I'm going to pick, let's see, I want it to be right about there. I'm going to pick that point right there. Okay? And that's going to be where my line goes through. Now, where is that point is the question. Okay? Alright, so that point is at 22 over and 18 up. So that's my line right there. You want to write that down. You're going to need that in a minute, okay? Alright, and once you move your cursor on Alex and click that button, the cursor will go away. So write it down before you click it. I'll show you what I mean when you get over there, okay? Alright, so now here's what I got to know. My slope is my rise and my run. So I went from positive 8 up to 18. What's my slope then? What's my rise? I went from 8. If I go from 8, where that point is, up to 18, where my next point is, how far have I gone up? So my rise is 10. Now, what's my run? From 18, from 0 here, I'm at 0 line, over to 22. So my run is 22. Okay? Now, this is one of those weird things that Alex will not let us put a fraction in. Gotta have a decimal number. So grab your calculator and divide 10 by 22. Okay? What do you get? Okay, good. The number after that 5 is a 4, so I'll round it down. I'll leave it right there. Okay? Now that I've got that done, guess where I'm at? I have my equation generator right. Y equals 0.45x plus 8. Like I said, the better numbers you pick here, where your points are, the easier it'll be to write that equation. If you pick crappy points, you put a dot in the middle, something like that, you're going to have a heck of a time finding where that dot's at. But if you pick a great point like 22 and 18, that's easy to count slope and rise and run, all that fun stuff. So the better numbers you pick, the easier it's going to be. You understand that? Okay, once you get your equation written, that's part A. Part B is now you have to use your equation. So this is my x number I got to put in my equation. So I'm going to grab my calculator. Okay, I'm going to grab my calculator here. I'm going to go 0.45 times 14 plus 8. This is my number for my next question, 14.3, or $14.30. That's how I get that. I use my equation and the number they give me. Everybody okay with that? Okay. And so if you draw a bad equation, you're going to get a bad number. Now, to check this off, how can I check this, make sure it's right? It's real simple. The answer is right here. Okay, if I go to 14 on the graph, 14 years is right here. It should be at $14.30 right there. That's barely above 14. That's about the right price to be. Okay? Okay, a couple things that people are messing up on. They're forgetting hey, what kind of correlation is this? Is it positive or negative? Then your slope better dang well be positive slope too. If it's a negative correlation, please make sure you have a negative slope. They kind of go hand in hand there. Okay? Alright? There's 3 of these, and these are the ones that I have the most questions on today, are these kind of things right here. And I will be more than happy to answer questions and help you out. But you can save yourself a lot of trouble by just picking really good numbers and making sure you have a positive or negative slope that correlates to your line, okay? Are we okay with that? Okay. All right, last one. On the next page. Okay? And this kind of ties us back to the last assignment we had in our class. We read the equation. We got the equation. Okay? Here's our scatter plot. Here's our line of best fit. Here's the equation for our line of best fit. What does the equation tell us? What does this 3.86 tell us? That's how much change there was. It's also called the slope, right? That's called the rate of change. So we find the question that has talked about change, and that's our answer for the change question. Okay? So right down here where it says, for an increase in 1 hour, that's a change of 1 hour. That answer will be 3.86. The question you don't do anything on except write the number down. The third question you have to do the math. But the first 2 questions, you write numbers down. Okay? What does the intercept tell us? Yeah, but what does it tell us? Which means that x is 0, right? That's our 0 question then. So when it says right here, what is the predicted midterm score for a student who does not spend any time studying? That means it's 0 time studying. That's your 0 question. That means he will get approximately a 16.56 on his midterm. I would not think so. Okay? Well, I'm thinking the higher scores are up here. I think that's probably a better score up there. Okay? The 0 term would be 16 points in right there. I think that'd be a bad score. Okay? All right, now the last question then, when it has a number in there, when they give you a number, you got to put that in the equation. So grab your calculator, okay? Okay? You go 3.86 times 12 hours, okay, plus 16.56. If you set it for 12 hours, you might get a score of 6288. Okay? Hey, guys, understand this. Okay? My nephew, who just graduated from medical school, okay, have to take what they call the MCAT test. It's the medical ACT test, the MCAT. Okay? He spent a month, every day, 10 hours a day for a month, studying for that MCAT test. Okay? All right? And he didn't get the highest score. But he got good enough to be accepted into medical school in 3 different schools. Okay? What I'm saying here? If you want to get into, if you want these things to happen, you have to study for them. They don't just happen. Okay? You understand what I'm saying here? So studying 12 hours, that's not a big deal. Seriously. Okay? These guys that do the LSAT, the LSAT, the MCAT, lawyers and doctors, they have to study to get this program. Okay? Okay, one more. So that's our last question. Now let's go look at Alex. Okay? Let's turn this off here.